Welcome to my house and my experiment. The lot slopes downhill to the shoreline, and the only place that I have access to the low winter sun is up here at the top tip of the lot on top of this granite bluff. In 1977, with only a few years of experience, I built phase 1, which is behind me here, over to the granite sail. The windows are oriented to the southeast. This is not ideal for capturing the low winter sun. It's one of the lessons that I learned from this and the other experiments that I've done over the years. Site designing is all about working with your site to enhance its benefits and mitigate its shortfalls. Passive solar design principles can work with any style home as long as it can accommodate southern-facing windows. This module will show you how to take the concepts that are in your head or on paper and bring them onto the reality of your site. In 1985, I took what I had learned and I built phase 2. It encloses the face of the granite bluff to a large area of south-facing glass, and now that granite becomes passive solar heat storage. Because we get high wind here, I decided to slope the glazing to deflect the wind up and over. But slope glazing creates summer overheating. It's great for the winter. Fortunately, we get the ocean onshore breezes here in the summer to mitigate that situation. I built an air recirculated heat storage slab system into the foundation. You will find this explained in my solar construction. The only place on my site with any depth of soil is right here. And so I dug, but it turned out to be a dry well. And so I turned it into a cistern. And then I built a solar woodshed on top of it. Now the rain and dirt that comes off the roof is put aside, and the remaining water is then filtered on the way to the cistern, and it's filtered on its way back. And in 40 years, I've never run out of water. You need to take what you have on paper and bring it on to the site. There, you can lay it out, you can rotate it, you can shift it, and you can make sure it's going to work. The seasonal sun cycle limits your gain in the winter, but more importantly, increases the amount of gain in the summer, contributing to summer overheating. It is essential to understand the seasonal weather patterns of hot and cold, of wind-driven rain and snow, storms and hurricanes on your site. The first thing is to develop an awareness and understanding of the sun cycle for all seasons. A compass is a good thing to start with. The compass method works even on a cloudy day when you cannot see the sun. It is useful to have a compass with a rectangular base to help you align and place stakes and markers for the south face of your home. The needle of your compass points to the magnetic pole, which is not true north. The difference between the magnetic pole and true north is called the magnetic declination and changes slowly over time. For our region, it currently is about 17 degrees west of north. With north, align square with the base. Turn the whole compass and base so the needle points 17 degrees west of north, as shown. Your compass base and dial will now be aligned to true north, east, south, and west. So, let us take our compass on site. First, find magnetic north. Then, adjust for true north. Our compass base will now be true north, south, east, and west. Be aware that near heavy metal objects, like your car or excavator, and high-tension electrical lines can affect your magnetic reading. With these important tweaks, you can now set an east-west line that faces true south to high noon. Your view may not be due south. With your compass base aligned true south, look at your compass dial to sight your view and determine how far it is off of south. Since the Earth rotates 15 degrees every hour and your compass is set to high noon, you can now relate your view angle to hours. 15 degrees is 1 hour, 30 degrees is 2 hours, etc. There are lots of apps available for your cell phone that allow you to use it as a compass. Be sure that it is giving you true north for your location and not just magnetic north. Let's say it's a sunny day and you want to find solar south, when the sun is at its highest point on its journey across the sky. To do this, you need to know the total time the sun has been above the horizon, the time from sunrise to sunset. Your daily newspaper, Weather Channel, or Environment Canada will give you these times. Take half the total hours and add them to the time of sunrise to calculate high noon. This will be when the sun is at true south. From there, you can begin to get a feel for the site. You can begin to see how to address site concerns such as views and solar obstructions. You can use obstructions to shade you from the high, hot summer sun, but not when they're going to block significant amount of your winter gain from the low winter sun. Orienting your home's windows to the sun when it is at its highest, true south, gives us the longest duration in both summer and winter. You need to account for this. The winter sun is above the horizon for a relatively short time and is low in the sky. As a result, it is more prone to being blocked by obstacles. Ideally, in the summer, we will orient within 30 degrees, 2 hours east, and 15 degrees, 1 hour west of south, to avoid overheating in the afternoon. In the winter, we would ideally orient within 30 degrees, 2 hours, of either east or west. This will give you a more direct and longer duration when the sun is at its highest. You need to prioritize this access during this part of the day and minimize obstructions. Remember that the sun shown is for the lowest sun on about December 21st. All of these considerations are site and microclimate related. You may already have a home design concept that works for your needs, and it may work for solar orientation and views. But will it work for all the other considerations that come into play on your site? So let us take a sample site to show you how to lay out, measure, and visualize how your concepts are going to actually work on your site. Installing power may require the removal of trees for the placement of poles and guidelines. Consider this early to minimize damage and to figure out how the services will enter your home, overhead or underground. Also to be considered is the future installation of photovoltaic panels, preferably on the ground. You will need to run conduit from your panel to where they will be located. Another consideration for your site is having access for vehicles. Vehicles have many requirements that take up a lot of space. Measuring them out and marking their outlines will help you visualize how they are going to work and impact your site. How is this going to work with multiple vehicles? What is the sequence of arriving and departing? Are you being invited to enter the home, or have you arrived at the garage door? On-site septic systems may take precedence, especially if there's only one place they can go. So you need to verify early the kind, the size, and where it will be located. Once you know this, you can now place your drilled well 15 meters away or your dug well 30 meters away. Collecting rain off of your roof can help charge a dug well, but it alone will not likely meet your full water requirements. But it might take some of the load off of your well. The slope of the ground affects just about everything, and you cannot see the degree to which the ground is sloped. One way to visualize the slope is to lay it out with a string level, as shown here. You can now see not only one line and measure the slope, but you can lay out multiple lines around the perimeter of your home, which will allow you to see the plane of a level floor. So how is your home going to fit into your slope? Here we can see that if the near corner is at grade, the far corner is going to lie like the bow of a boat into the ground by about a meter's depth. Because of the slope, surface rain runoff from uphill will be coming down the hill and will have to be diverted around the home. On the near side, it will flood the entry area and driveway if it is not diverted somewhere else or drained subgrade to below and beyond that area. On the far side, the runoff is diverted away, protecting the septic field. The design of your home should evolve in tandem with your site design. How well this is going to work depends on your sensitivity to your site and how you adapt it to your needs. As shown here, you can now pretend to enter your home, sit in the living room, or stand in the kitchen, where you can now look out your windows to the sun, the views, and who is coming up the driveway. Before construction begins, prepare your site with the advice from those who are going to be doing it, and figure out the process and the sequence. Decide and mark trees that are to be saved. Show them the house plans and how it fits on the site. Show them your driveway, septic field, well, and home layout, where soil is to be stocked ready for backfill, machine size and access, and so on. Everybody involved, especially the machine operator, needs to know what they are about to create. The design of your home begins with your site design, and it needs to happen in tandem with the design of the home. You need to bring the two together in harmony. This may take some creativity, but it will result in a more sympathetic, less intrusive, and less expensive project. You need to spend a lot of time on your site. You will get a feeling for how it changes with the weather, with the seasons, and the time of day. There is no other way.